Hey everyone, I just wanted to make a video for you about graphing lines. This module you'll be doing a lot with lines, and I know sometimes it can be a little bit tricky with just the way that the program is that you're using and that you're graphing on, that you might have some issues there. So let me give you some helpful hints and tricks to help you with that. So let's start off with graphing this equation given here, the x minus 2y equals 2. Well, with something like this, there's a couple of different ways that we could go about graphing it. And so one of the ways that they talk about in the module is using the intercepts method. So where you're finding the x and y intercept to graph those. So to find the y-intercept, we let x equal 0, and then we try and figure out what y is when x is 0. And then just kind of opposite of that, to find the x-intercept, we let y equal 0 and solve for x. And when we do that, that's going to give us 2 points on there, one on the x-axis and one on the y-axis, and then we can connect those two dots together to solve it. So let's go ahead and start off with finding the y-intercept. So on this one, we're going to let x equal 0. And when we do that, we're going to put 0 right there in place of x. So I'll have 0 minus 2 times y equals 2. Well, that 0 doesn't really mean anything there to us. So I'm just going to kind of cross it out there. So we really have negative 2y equals 2. And so to get y by itself, we just need to divide by negative 2. So when we do that, we get y equals negative 1. So that's telling us when x equals 0, y is negative 1. And we can write that as an ordered pair as 0 comma negative 1. All right, and then I'm just going to put in here that when x is 0, y we found to be negative 1. Okay? And then let's do the same thing for our x-intercept now. To find our x-intercept, we're going to let y equal 0 and then solve for x. So when y equals 0, we have x minus 2 times 0 equals 2. Well, 2 times 0 is just 0, so let's cross that out, and now we have left x equals 2. So this is telling us when y is 0, x is 2, but if we write that as an ordered pair, that's 2 comma 0. All right, and so here we'd have 2. All right, and now I have 2 points that I can graph on my grid, and let's do these in the different colors that I have here. So 2, 0, so over 2 up 0 is here. And that is my x-intercept. And then if I do my y-intercept is 0, negative 1, so over 0, down 1 is there. And then I can just connect those two dots together and make a line that goes through both of them. And we'd have something like this. Okay? So with this, sometimes it gets tricky because people get some fractions, and that's the part that's kind of hard on the computer program, is it's not going to allow you to do different kind of like fractions. It needs to be whole number answers, but you can see here we got some whole number answers. Now another method that we could use that you'll see where kind of a fraction comes into play is if we use this y-intercept and slope method. So let's take the equation that we're trying to graph, right? So this x minus 2y equals 2. And we want to solve this for y, so get y by itself in order to use this method. So we'll start by subtracting our x over to the other side. And when we do that, we have negative 2y equals negative x plus 2. But then y is not by itself yet. We need to divide everything by negative 2. All right, and so when I do that, my y is now by itself. I get y equals, and negative divided by a negative is a positive, and this is kind of like there's a 1 there, right? So I have 1/2 x minus 1. All right, and then when I get it into this form, this is called slope-intercept form because this 1/2 is my slope and this -1 is my y-intercept. And you can see that that's what we came up with over here, right? When we found our y-intercept before, we found that it was -1. That also corresponds with that -1 here when it's written in this form. So what we want to do first is when we're graphing this, we're going to first graph the y-intercept. So you have to start with that. So on the y-axis, we're going to go down just one place there. All right, and then from there you're going to use the slope. Now remember, slope is the same thing as rise over run. And so rise means how far up or down you're moving. So if this was a negative number, you'd be moving down, but it's a positive number, so that means from our y-intercept we're going to go up one place. And then run means how far left or right. And so this 2, since it's a positive 2, it's telling us we're going to go right 2 places. If it was a -2, we'd go left 2 places. So that would be there. And you can see that we found those same points using this method. And it's not always that you'll find the same points there, but you can tell from this that this is indeed the same line, just a different way to get there. All right, so those are 2 methods. So the form of this is what's called standard form. And when it's in this form, oh, actually, I'm so sorry, that's actually called general form. Let me get rid of that. Okay, so general form is when you have the x and y on the same side of the equal sign and then the whole number on the other side of the equal sign. And when it's in this form, it can be maybe easier to use this intercept method, but you could still get weird fractions and stuff if you're using this method if these numbers don't divide, evenly. Like say that there was like a 3 or something in front of the x. And then we'd have to divide it by that 2, well, you'd end up with a fraction there. So, but it is one good way when it's in that form to use that intercept method. But the other way is just change it to that y equals mx plus b form, the slope-intercept form, and then you can use the y-intercept and then the slope from there. All right, let's look at one other problem here. And then hopefully these will help you. So what if we start off with something like this? So we were asked to graph f of x equals 4/3 x plus 1. Well, remember, f of x really is just the same thing as y. The only reason that we write it as f of x is to tell us that it is a function, because there's special things that we can do with functions that we can't do with just any equation. Right? So it's just kind of telling us that. And then there's 2 different methods that we could use if it's already written in this slope-intercept form, that y equals mx plus b form. All right, we could make a table of values. So you pick your x's. Now, the x's that I have written down here are specific. So 0 is always a good x to pick. All right, but notice that I'm choosing 3 and -3. And that's because my denominator is a 3. I want to have my x as multiples of 3. If I chose like 1 or something like that, it's not that that's wrong. It's just that it's going to give me a fraction for my y, and then the graph, the program that you're using to do your homework on isn't allowing you to be able to graph that. So that's why we want to pick values like this, right? Values that are multiples of whatever the denominator is. So if it was, the denominator was 2, you'd want to choose x's that are multiples of 2. If the denominator was 5, you'd want to choose x's where the x's are multiples of 5. Okay, so let's just put these in really quick, and I just left this space here in the middle so that we could so I could show you some work here of what I'm doing. So I take that 4/3 and I'm going to times it by 0, and then add 1 to it. Well, 0 times anything is 0, plus 1 is 1. So I just found one ordered pair is 0, 1. All right, then let's go down to this one now. Let's put 3 in place of my x. So if I have 4/3 times 3, which is really 3/1, and I'm going to write it that way just because it will make it easier for us to see some things here, and then plus 1. So notice that these are connected by multiplication, and when I have the same number on the top and bottom that are connected by multiplication, I can divide those out. So I'm really just left with 4 on this part. So I have 4 plus 1 gives me 5. So my next point that I have there is 3, 5. Right? And then I could do -3 also for that. So 4/3 times -3/1, and then plus 1. All right, well again, I've got those 3's that divide out here. However, I'm still left with a -1 there, right? Because that was a -3. So I have 4 times -1 is -4, and then -4 plus 1 gives me -3. All right, so I got -4 there, plus 1 is -3. So another point is -3, -3. All right, and then you could do another point there. 3 points are probably the minimum that you want to do when you're using a table of values like this. So let's go ahead and graph these on here. Let me plot these points and see if we can tell what this line's going to look like. So over 0 down 1 is here. Over 3 up 5 is there. And over -3 down 3 is here. All right, and then these should line up to be on, whoops, what did I do there? Did you see the mistake that I just made there? I put that, oops, let me erase that. That was supposed to be 0, +1, and I put it as 0, -1. So over 0 up 1 is there. And the reason why I could tell I made a mistake was because it wasn't going to make a straight line there. It was kind of going down and weird, it was going to make a weird V-shaped thing. So then it made me look over there and said, oops, I got that negative wrong there. All right, and so then, oops, it's always so much harder to draw it on here. Luckily on yours, on your homework, it just draws a nice straight line for you anyway. But that would be what our line looks like. Okay, and then lastly, you could still use that y-intercept slope method that we used on the one above, meaning, so let me write it this way, so y equals 4/3 x plus 1. All right, so when it's in this form, remember that number in front of the x, it has to be in this form though, right? This is my slope, and 1 is my y-intercept. So let's plot that y-intercept first. So that would be on the y-axis. I need to go up 1 because it's a +1. And then from there, I'm going to go up 4, right 3. All right, so from there, go up 4, 1, 2, 3, 4, and then right 3, 1, 2, 3. All right, or remember with my slope, I could go, if I had -4 over -3, all right, a negative divided by a negative is still positive, so this is saying the same thing, but look at if I graphed it on here, if I went from there and I went down 4, 1, 2, 3, 4, and then left 3, 1, 2, 3, it would be here, and you can see those are still on the same line there. So I hope that helps you to kind of see different ways that you can graph these, give you options, so that if you do come up with some fractions that you're not sure how to use, or on the homework, that you can use one of these other ways to do that. Hey, if you have questions, please reach out to me for help. Thanks.